Hello, everybody. I just wanted to kind of introduce you, and I know some of you have done this already, and hopefully, with some of your other AP courses, you've done some of your progress checks. But we are going to start with reviewing for the AP exam. And um, as you may have seen in the update that I sent out on Schoology, they're only going to test units 1 through 7. So, what I'd sort of like to do to get ready for that is go through units 1 through 7 each day. We'll do for your Monday, Tuesday courses today, we'll do unit 1. And then for your Wednesday, Thursday, we'll do unit 2. Then we have a week for spring break. And then we'll pick up where that left off. A lot of things are in the air right now in terms of AP. April 3rd seems to be a big day where they are going to give us some more information about the exam. As you saw, the exam it's going to be given at home if you still want to take it, and it's going to be 45 minutes in length. It looks like it's going to all be free response, okay, and no multiple choice, which I know we've kind of been getting ready for that multiple choice. But almost every question that was at the end of any of your exams was a long free response question from College Board. So you are prepared for those as well. Plus, we have our final exam to think about as well. That's going to be multiple choice and some open-ended free response in your final exam. So it's good to do both. It does teach skills as well for even doing the multiple choice. So this may be an opportunity. I don't know, and it's just totally speculation. But with this 45-minute exam, only 7 units, could be an opportunity for you to get a very high score by continuing to take it. That's up to you. Again, they said that they would. I think they will waive any cancellation fees or anything like that if you do want to cancel. But I would, we've done a lot of chemistry, and I would love for you to still take the test that you signed up for. Okay, so what I'm going to ask you to do for today and tomorrow, okay, so the Monday Tuesday class, is to take your personal progress check or your project progress check on Unit 1. Okay, I did assign this a long time ago after we got all of Unit 1 completed, but we never did it in class. And then I thought to myself, I'm going to save it until we review. And I was going to plan on doing this even if we were in school. There are 5 of you that have started the multiple choice, and there's one single person out there that started the free response. Okay, but for everybody else, you can log into your AP classroom, and it will be assigned your progress check, your MCQ, your multiple choice questions, and your FRQ, your free response. Okay. So that's what I'd like you to do for Unit 1. Okay. We just finished all of our content with Chapter 18. I'm not planning on having a Chapter 18 test on electrochemistry. Electrochemistry is actually one of the units that is not going to be on the actual AP exam. It's in Unit 9. So I think we're good where we're at. I'm just going to kind of assess you by these progress checks. We're going to do units 1 through 7. Okay, just to review real quick, Unit 1. And Unit 1 is pretty basic, but I do want to mention some things. I'm going to pull this up right here, and you can take a look at the different topics of Unit 1. The first topic for Unit 1 is moles and molar mass. So what's the enduring understanding? The mole allows different units to be compared. So you can convert between moles and grams, moles and liters of a gas at STP. Moles is our fundamental quantity in chemistry. So what do you have to do? Calculate quantities of a substance or its relative number of particles using dimensional analysis and the mole concept. So knowing Avogadro's number, 6.022 times 10 to the 23rd, that is on your equation sheet. Being able to express the mass of an individual atom in AMUs. This equation right here, the number of moles is the mass in grams of the substance divided by the molar mass. And that's really not, that equation is on the equation sheet. It's not really one that we sort of look at to use because it's just so innate that you have to divide your mass in grams by the molar mass to get the number of moles. So your grams cancel. So that's kind of what that equation means right there. Okay. Our second topic for Unit 1 is mass spec. So we did look at mass spec previously in chapter 3. And remember what that is. That's a machine that breaks the atom or a sample of atoms into its individual isotopes. Okay, remember it has a big magnet and an electric field that has those turn around a corner. The more they're deflected, the lighter they are. The less they're deflected, the heavier they are. And it can show you kind of like a bar graph of the individual isotopes of those elements. So explain the quantitative relationship between the mass spectrum of an element and the masses of the element's isotopes. Remember, from relative abundance and the different masses, you can get the average atomic mass. You can calculate that. So if you know that 53% were this isotope and 47% were this isotope, you could get the average. One thing you don't have to do is, multiple atoms of different types and things like that. That's not on the AP exam. Okay, section 1.3, elemental composition of pure substances, the enduring understanding, chemical formulas, identify substance by the unique combination of atoms, explain the quantitative relationship between the elemental composition of mass and empirical formula. So that's really just an empirical formula calculation. Remember, if you're given percentage data, change that to grams, grams to moles, divide by the smallest mole amount, and then get your whole numbers. And those whole numbers are your individual number of atoms in a compound. Okay. And that's kind of what it talks about here in this essential knowledge. So you can read through this, kind of pause if you want and read through these different topics. Those personal progress checks will show you some of these things as well. Excuse me. So let's kind of move on. Topic 1.4 from Unit 1, composition of mixtures. Not too much here. I very rarely see any questions on the composition of mixtures on the AP exam, but chemical formulas identify substance by a unique combination of atoms, same enduring understanding. Explain the quantitative relationship between the elemental composition and the composition of substances in a mixture. In your essential knowledge, while pure substances contain molecules and formula units of a single type, mixtures contain 2 or more types. Elemental analysis can be used to determine the relative number of atoms in a substance and to determine its purity. And that purity is just kind of like a percentage of pure versus whatever else is mixed in there. Okay. Electron configurations. Okay. An atomic structure. Atoms and molecules can be identified by their electron distribution and their energy. Represent electron configuration using the Aufbau principle, building up 1s, 2s, 2p, 3s, and so on. Remember, the atoms are composed of negatively charged electrons, a positively charged nucleus, and Coulomb's law, Coulombic attraction. Anytime you have 2 charged particles, whether it be ions for like lattice energy, whether it's the proton to the electron, it is Coulomb's law that shows the strength of that force. And remember, it's sort of proportional to the charge over the radius. So the larger the charge and the closer they are together, the stronger that force. So remember, if you have an electron that's very close to the nucleus and held very tightly, it's going to have more ionization energy to remove it. Conversely, if you have very small ions of high charge in an ionic substance, very high lattice energy. Okay. And this just talks about, basically writing your electron configurations. This is saying you don't have to use quantum numbers. You don't have to know quantum numbers. We didn't even go over quantum numbers. I took that out. Okay. And this is just talking about ionization energy. The relative energy required to remove an electron from a different subshell of an atom or ion from the same subshell in different atoms can be estimated through the qualitative application of Coulomb's law. So this energy is related to the distance from the nucleus and the effective charge in the nucleus. So again, why do atoms get smaller as you go across the period? That is because of Coulomb's law. Okay, you're adding to the same energy level, charge, Pulling them tighter together, they get smaller. Okay. All right, a few more left. Photoelectron spectroscopy. Remember what that is. That sort of measures that energy required to remove an electron, all the electrons. And remember, the height of the peak represents how many electrons were at that given energy level. And this is what really validated the Aufbau principle and sublevels and subshells, 1s, 2s. The 1s is always the hardest to remove. It's the closest to the nucleus. There's no shielding. The Coulombic attraction is the greatest. So take a look at those. There always seems to be one of these on the exam where you have to look at the peaks. And remember, the height of the peaks represents how many electrons there are. From the peaks, you can get the electron configuration. From the electron configuration, you can actually identify the element. Okay, so that's basically what it's saying right here. Okay, periodic trends, topic 1.7. Explain the relationship between trends of atomic properties and elements and atomic structure and periodicity. Here's the four you need to know. Okay, ionization energy, atomic and ionic radii, electron affinity, and electronegativity. So these are those trends based again in Coulomb's law. Why does ionization energy increase across the period? Why does it decrease down a group? Going across the period, the electrons are held tighter, takes more energy to remove it. Going down a group, they're held further away, there's more shielding. And remember that the reason for that period trend with atomic radius and ionization energy is what we call effective nuclear charge. And that's why Coulomb's law pulls those electrons in tighter and holds them tighter. Okay, so just review your trends that you see there. Okay. Valence electrons, section topic 1.8, valence electrons and ionic compounds. Remember, it's the valence electrons that gives the stability to different substances, whether they're ionic or covalent. The likelihood that two elements will form a chemical bond is determined by their interactions of the valence electrons in the nuclei. Elements in the same column of the periodic table tend to form analogous compounds or the same types of compounds. Typical charges of atoms in ionic compounds are governed by their location on the periodic table and number of valence. And that's just saying, well, alkali metals form a +1. Why is that? Because they have one valence, they lose that one. Alkaline earth metals +2. Halogens -1s. Your oxygen group -2s. And that's kind of all that's saying right there. Okay, so those are the topics for Unit 1. Make sure you go back and review those and then complete your personal progress check, both the multiple choice and the free response. And that's what you have to do for today. Have a great day.